All right, let's go ahead and look at number 1. It says the results of a survey concerning participation in sports are shown in the table. Which of the following statements would be a reasonable prediction if the survey were expanded to include 100 students? Okay, so let's just go ahead and start out. We know that we're going to need the total, right? So 8 plus 2 is 10. 1, 2, 3, 4. So the total here is 40. So for us to be able to look for a reasonable prediction, right? So something that could be true, let's go ahead and find out what each of these amounts would be if there were 100 students. So right now they're saying that for baseball, there are 10 out of 40 students, right? We can cancel that out of to 1 out of 4. So if 1 in 4 students participates in baseball, how many out of 100 students, right? So you can do your cross product, or you can think, I know that 4 times 25 is 100, so 1 times 25 would be X. So, right, so baseball would be 25 students out of 100. I'm going to put that new total here. Then we have basketball. Which is 12 out of 40. I can reduce that by dividing by 4, right? So 12 divided by 4 is 3, 40 divided by 4 is 10. So if 3 out of 10 participate in basketball, that's going to be how many out of 100? So I know 10 times 10 is 100, so 3 becomes 30, right? So that's 30 students would participate in basketball. And then last but not least, football. So there's 18 out of 40. So I can divide by 2, I get 9 out of 20, right? So 9 out of 20 equals how many out of 100? So I know that 20 times 5 is 100, so 9 times 5 is 45. So that's going to be 45 here. Okay, so now we're ready to go ahead and make predictions. The number of students choosing baseball or basketball would equal those choosing football. So baseball is 25, or basketball, so 30. So it's saying 25 plus 30 would equal 45. Well, 30, 40, 55. So that's not true. Let's look at the next one. 30% of the students surveyed would choose basketball. Okay, so that one takes a little more calculation. Let's keep looking. Twice as many students would prefer basketball to baseball. So twice as many basketball to baseball. So twice as many would prefer basketball to baseball. So that's saying it's a little tricky, right? So twice as many prefer basketball. So twice baseball, which is 25, would equal basketball. Well, that's not true. Okay, 40 students would choose basketball. Let's see, basketball is 30 students versus 40, so that doesn't seem right. Let's go back to this. 30% would choose basketball. So 30%, 30 over 100 is how many over 100 students, right? So that would be 30 students. So do 30 students prefer basketball? Yes, right? So that means B would be our answer. All right, let's keep moving. Okay, the spinner below was spun 24 times. I'm going to move it down so we can see everything. The results of the 24 spins are recorded in the table. Which of the following statements is true based on actual results from the spinner? All right, so the theoretical probability of landing on a red is greater than the experimental. So let's find what's the probability of red. I'm going to put TP for theoretical probability. So red, there's one red out of 4 sections. Okay, so we want to compare that. I'm going to write it down here. So theoretical probability is 1 over 4. We want to compare that to the experimental. So we know that there's 24 spins, right? Total. I'm going to write it down there so I don't forget. So the experimental probability of red is 7 out of 24. Well, I can't reduce that. So let's see. Experimental probability is 7 over 24. Well, it's hard to compare them with different denominators, right? So can we make this into something over 24? So we can compare it. Let's see, 4 times 6 is 24. So 1 times 6 is 6. So 6 over 24 versus 7 over 24. So is 6 over 24 greater? No, it's less than actually. So that's not right. Let's look at the next one. The experimental probability of landing on a pink. I'm going to go ahead and see if I can get a pink. Oh, well, we'll deal with blue instead. Pink is equal to the theoretical probability. So pink is going to be the same, right? So let's see, the theoretical probability of pink is going to be 1 over 4 because they're all the same. And then the experimental probability, let's see, experimental probability of pink. Oopsies. Oh, no, stop. Oh, no, it's deciding to have a mind of its own right now. Okay, sorry. Okay, so the experimental probability of pink is 6 out of 24, right? Well, we could reduce that. If we divide by 6, we get 1 over 4. So the experimental probability is 1 over 4. So it's equal. Well, that looks good, but we have to keep checking, okay? Oops, I keep going too far. Okay, we're going to keep checking. So let's see. What about the experimental probability of landing on blue is less than the theoretical probability? So we know again that the theoretical probability is 1 over 4. Let's find the experimental probability of blue. So blue is 7 out of 24. And I can't reduce that, but I know that, let's see, 7 over 24. I know that 1 over 4 equals 6 over 24 because we figured that out in A. So it's saying that the experimental is less than. Well, that's not true because 7 is greater than 6. So that's not true. All right, last one. Theoretical probability of landing on green is less than the experimental probability. Okay, so the theoretical probability of green, so it's 1 over 4, is less than, is what they're saying. Well, we don't know that yet. Is less than the experimental probability of green. So experimental probability of green is 4 over 24. So let's see. Experimental probability is 4 over 24. I know that this is 6 over 24. Well, that's not less than because it's actually greater than. So we have our answer back up here with B. Okay, good job. So these last two are spiraled problems from before Christmas break, but you will see some spiraled problems on your math test. So let's take a look. Triangle XYZ is similar to RST. What is the length of RT? So let's see, I want to find RT. I'm going to go ahead and put an X here. Oops, hang on one second. It's working again. So RT is similar, so we know that is a corresponding side by looking up here, RT to XZ, so XZ. And so then let me find another set of corresponding sides. So I only have this one over here, so I'm going to have to use ST. Sorry, my lines are wavy. ST and YZ. Okay, so now that I know that, I can go ahead and set up my proportion with corresponding sides, right? So I can either do the two reds, so 5 over x equals 6 over 15, or you guys could write shape by shape. 6 over 5 equals 15 over x. Either way, we have 6x equals 5 times 15. So 15 times 5, 5 times 5 is 25, 5, 6, 7, 75, divide by 6, divide by 6. So 75 divided by 6, 1 times 6 is 6, 15, 2 times 6 is 12, 30, 5 times 6 is 30, so 12.5. Huh. I mean, look, it looks right, so I don't think that the right answer is on here. So 12.5 is what it should have been. Okay, sorry about that mistake, but let's go ahead and look at the last problem real quick. Mrs. Smith, the school nurse, randomly selects 7th graders to participate in a district survey about height and weight of students. The survey results for the heights of the 7th grade boys and girls are shown in the box plots below. Which of the following is not supported by the data? So let's go ahead and take a look. This one says the median height of 7th grade boys is 3 inches shorter than the median. Okay, so we know that we should go ahead and analyze our two graphs. So range, right, is maximum, so 62, minus minimum, 52, and then the median is right here in the middle, 57. Let's go ahead and look at the other one. So the girls, the maximum is, so range is 68 minus the minimum, oops, down here, sorry, 52. So 62 is 10, 16, right? All right, and then the median is the middle here, so we have 60. Okay, so now we're ready to take a look and compare. So the median of the boys is 3 inches shorter than the median of the girls. So median of the boys, 57, so plus 3, right, is 60. Well, that looks true. So we're looking for not supported by the data. Okay, interquartile range for the heights of the 7th grade girls is 1.5 times the interquartile range for the boys. All right, let's go back and look at our interquartile range. So the IQR is going to be the box, right? So 60 minus 55 is 5. And then is 65 minus 57 is 8. Okay, so let's see, for the girls is 1.5 times, so it's saying 8 is equal to 1.5 times 5, right? So 1.5 times 5, 5 times 5, 5, 7, well, kind of. All right, you guys keep checking. Go through C and D. Okay, guys, so I looked at D, and that is right. So we're down between B and C. It talks about the data being skewed. I don't feel like the data for either is skewed. They look about symmetric. So I'm going to say since it's about 1.5 times 7.5 is about 8, I'm going to go with that is correct, and that C is the right answer. Good luck on your test tomorrow, guys. Make sure you study, go over all of your probability and everything like that. Good luck.